Hello everyone. In this lecture, we are going to deal with the fifth module of Civil Engineering and Project Management. This module is based on mainly two things. First one is materials management and the second one is safety. Material management mainly deals with the inventory control measures that can be applied in this aspect of management on materials. And the second part, safety, as civil engineering students, we have to deal with what are the safety measures that has to be taken into consideration in a construction site or a civil engineering project site. Dealing with the syllabus of this module, concept of material management, we will be dealing with what are the elements in material management, what are the objectives of material management likewise. Then we will be seeing what is meant by inventory, then inventory control measures, mainly EOQ, economic order quantity. Second one is ABC analysis, always better control analysis. Like I said, in the second part, we will be dealing with safety in construction and its importance, safety measures in different stages of construction, and its implementation of the safety program. And dealing with the introduction of material management, we know that what is meant by a material. A material is a whole range of goods and services procured from sources outside the organization and processed to provide finished products for sale. As the definition says, it can be either a good or a service which is procured from outside as raw material, then it is undergoing some kind of processing inside the organization or inside the processing unit, and finally it becomes a finished product. And this management is very important because this management or material type of material varies in different aspects. It can be different in factory or it can be different in a construction project. So we need to have an integrated approach towards material management so that material can be properly managed for the efficient flow of the work and also for increasing the efficiency. Then this is the official definition of material management. This is a process of management concerned with planning, organizing, controlling of the flow of materials, like we said, to, through and out of an organization in an integrated fashion. Material management is an integrated approach which ensures efficient flow of materials, which means that optimum use of materials throughout the processing time. We all know that what is meant by management. Management is nothing but which provides minimum input and which gives us maximum output. Likewise, in material management, this can be rewritten as something that provides minimum expenditure and maximum utilization. So material management ensures that the materials can be properly monitored, can be properly optimally used so that this process goes on without any interruption. So it deals with planning, organizing, controlling of flow of materials to as raw materials, as processing materials, and out of an organization as a finished product in an integrated fashion. Then we have to see why material management is important. What is the necessity of material management? In the construction project, we could see that material cost alone sums up to 55% of the total cost of the construction project, and 25% labor cost, 5% POL cost, then other overhead or indirect cost, tax components likewise. So more than 50% of a construction project cost lies with the material cost. So it is very important for us to have a good management for the materials from the starting towards the end of the construction project. We know that materials can be classified into two, direct materials and indirect materials. Direct materials are nothing but the raw materials which are to be processed and which are to be made to be a final product, while indirect materials are nothing but the tools, accessories or other spare parts that is required for everyday operations to make this direct raw materials into a finished final product. Then why this is required? Like I said, it costs about 55% of the total construction project. Therefore, material management is very important. The next thing is that there are different kind of materials. Some require specific care, some does not require that much care. So we have to identify which are the materials that require special care and attention, and those care and attention should be provided for the procurement, storage, handling and distribution of such materials. If we are not identifying such materials and if we are not providing good facilities for those kind of materials, we can see that the cost for some of the materials may get degraded or may get destroyed. So we have to spend extra money for carrying out the processes. So complications in dealing with raw materials, brought out components, sub-assemblies, etc. underscore the need for systematic management, like we discussed. Some components have specific uses and low flexibility, while others have many uses, require more care in procurement, storage, handling and distribution. Like we said, material management is meant for maximum coordination or maximum expenditure so maximum coordination or maximum utilization and minimum expenditure on the material, which means minimum input and maximum output. Now we will be seeing with what are the objectives of material management. We have around 6 to 7 objectives of material management which are very important. You have to understand, if we know the necessity for material management, you can easily write down the objectives for material management. The first and the foremost one is 5 rights. The right item of right quality, in the right quantity, at the right place, at the right time, for ensuring uninterrupted execution of work. There should be a uniform flow of processing materials. There should not be any delay, there should not be any interruption to the work that is being carried out. For that, we need to have 5 rights. We should have the right correct item, second one of the right good quality, of the right ample quantity, at the right place, at the right time. Then only we can say that there is an optimal flow of resources or optimal flow of materials, and there is no interruption in the execution of works in the processing organization or the processing factory or the construction site. Second one, to ensure a uniform flow of materials for production, like we said from the first point where we have stopped. The next point is uniform flow of materials. There should not be any interruption to the work being carried out. Therefore, flow of materials should always be facilitated for the execution of the works. Third one, ensure lower departmental cost, better customer service and maintain ethical standards and practices, which means that the products provided should be of good quality, good quantity, it should be of good efficiency and all, which means that ethical standards should be upheld or ethical standards must be practiced. There should not be any malpractice in any word from the starting point to the ending point. The fourth one, reduce cost of materials through the use of scientific tools and techniques. So this means that we have to clearly identify which all are the critical materials which has to be taken care of. There may be many number of materials in a site, of which very few, likewise say 1 or 2 may be requiring, which may be critical. So we have to provide extra care for those materials, otherwise those materials may get destroyed over a period of time. So we have to analyze through scientific tools and techniques which are the methods or which are the materials that require specific attention, and what are the methods in which those can be properly procured, those can be properly stored, those can be properly handled, so that we can reduce the cost of materials or the maintenance of materials. The fifth one is the efficient use of inventories, which helps in releasing the working capital for productive purposes. Which kind of inventory control measures can be properly chosen, for that the material management can be done properly. Next one, sixth one, modify paperwork procedure to minimize delays in procurement. So if we are going through a work, and if we need to procure some material at the earliest, and if we are going through a lot of paperwork, then it causes delays which causes interruption to work. So this has to be avoided. So modify the paperwork procedure to minimize the delays in procurement. Train the personnel to increase the operational efficiency. So we'll be seeing carrying out different iterations in which we can provide optimum utilization of resources, thereby increasing the operational efficiency. To remove the issues of unavailability of materials and unavailability of tools on the construction site. It's nothing but to remove the issues of unavailability of direct materials and unavailability of indirect materials on the construction site, which supplement all the points discussed above. So these are the major terms which we see as the objectives of material management, and all this can be summarized in the first point itself. 5 rights: right item, right quality at the right place and at the right time without interruption on the execution of the work. Next, we'll be seeing some terms associated with this material management, which we will be seeing in the further slides. First one is stock. Stock is nothing but some goods in the premises of the business or a warehouse that is available for sale or distribution, that is ready to go to the market. An inventory can be total quantity of material available in the store. So if you read for the first time, you may not see any difference between stock and inventory. But stock is something that is ready to go for the market, but inventory involves even the raw materials also that is available in the store. It can be inventory involves material that can be in the raw material stage, that can be in the half processed stage, or that can be as a finished product. So those all categories comes under the inventory, while stock involves only the completed finished products that are ready to go for the market. Logistics, as you all know, logistics is defined as a function of moving, storing, and distributing resources and goods, the process of movement. Then purchase cost is nothing but the actual cost of the material. Carrying cost is nothing but the cost of using or borrowing money. So these are the major terms that is related with this inventory control or material management. Next, we will be going to deal with what are the elements of material management. And this can be classified as a cycle or a chain, starting from the demand estimation, then going to the procurement, receipt and inspection, storage, issue and use, maintenance and repair, condemnation, disposal, and again to the demand estimation. We will be seeing one by one what are the elements of material management. The first one, it is selection and demand estimation. First, we have to prepare a list of essential materials that are in accordance with the standards. For example, if our product which we have to procure is hospital drugs or any kind of construction materials or any kind of materials, there should be certain standards put forward by the authorities, and those standards has to be satisfied while we are procuring the materials. So when we are preparing an estimation or preparing an estimate, or when we are going for a selection, we have to have in mind what are the essential materials that we need. At the same time, those should be prepared based upon the standards put forward by the authority. The second one is procurement. Procurement means first, once we have made the estimation, then we have decided to select the materials, then next one is procure the materials from outside to the processing unit. So process of acquiring the supplies, like we have said, 5 rights. It should be of good quality, it should be prompt, it should be timely procured, then it should be uniformly distributed. Then all these materials, the procurement should be done based upon in a transparent way, inviting tenders and contract. So first one is selection and demand estimation, second one is the procurement. The third one is receipt and inspection. Once we have decided to procure, then we must have received the product or raw material in our construction site or in our organization. Then we receive the supplies in our stores or warehouses. We physically check the supplier's invoice, what are the quantity of materials, quality of materials, and randomly we will be going to have a chemical inspection or a detailed inspection on the materials received. We will not be checking or inspecting all the materials detailedly. We will be having a physical check on all the materials that is coming into the organization, while randomly we will be selecting some of the materials and we will be going for a detailed inspection or a chemical inspection. The fourth one is storage. and we have collected the materials and we have received the receipt, as well as we have randomly checked the materials till now. Next step is to store this materials properly or efficiently within the warehouse or within the production unit. So it should be categorized based upon many factors. The basic ones can be like whether the material is combustible or non-combustible. So usually we follow a two bin system known as the working bin and the reserve bin, and here we could see that it is being illustrated in 5 stages. Stage 1, we will be having the bin 1 and bin 2. Here bin 1 is the working bin and bin 2 is the reserve bin. And since bin 1 is the working bin, the materials in the bin 1 gets reduced once the process is being carried out. So the material gets reduced, while in bin 2 the materials is kept as it is, since it is a reserve bin. In step 3, we could see that the first one, the working bin or the bin 1, gets emptied because of its process carrying out. Then they will start using the bin 2, and it is recognized as the time to place the order to fill the bin 1 again. Otherwise, if we wait till the bin 2 gets completed, then we will not get much time to place the order, receive the materials, procure the materials, and do all the necessary steps and fill this bin. Then there may be chances that the work may get interrupted. To avoid that, this is followed such that as soon as the working bin gets completed or emptied, the next order will be placed and the reserve bin will be activated. So the materials will be procured from the bin 2 or the reserve bin in the stage 4, and in the stage 5, when the bin 2 becomes 50% of its capacity, when 50% of the material gets emptied, then the bin 1 gets filled up. So which means that when bin 2 gets over, again the working bin becomes bin 1 and bin 2 will be filled as soon as possible. So this is the methodology that is being followed in a material management good method, and that is said to be as the 2 bin system, in which one is the working bin, another one is the reserve bin. The next one is issue and use. So once we have stored, we have to utilize that upon request. So there can be 2 methods. First one is the push method and the second one is the pull method. Push method is also known as the allocation method, and pull method is said to be as the requisition method. So when we deal with the push method in this, the assumption is that the supply chain is proactive in nature. The products are ordered prior to the actual orders, or order volumes are based in forecasted demand for an item. But in pull method, also known as the requisition system, the assumption is that the supply chain is active in nature and based upon the actual demand only. Products are ordered only after the order comes from the customer. So those are the difference between push method and pull method, how the material is to be released from the area of storage. The next one will be going with maintenance and repair. So once the direct materials are being processed, there may be some maintenance or repair required for the indirect materials or the spare parts which make this process happen. So those has to be carried out properly. Next one is condemnation. Sometimes some materials have to be rejected when it does not maintain the required quality or standards. So those has to be rejected properly, which is the next element of material management. And of course the last one is disposal. Safe methods should be employed. We all know that there may be some byproducts or waste products from this processing units, so those has to be disposed of properly so that there does not create any environmental issues or harm to the environment. So these are the major elements of material management, starting from demand estimation, selection and demand estimation, procurement, receipt and inspection, storage, issue and use, maintenance and repair, condemnation, disposal, and again it is to the demand and estimation. This process starts over once again from the procurement or pre-procurement stage like selection and demand estimation. Now we will be going to an important topic known as the inventory. So last few slides before, we have seen what is actually inventory and what is actually stock. Those are a little bit different. When we read for the first time, we will not feel the difference, but they are entirely different. stock is something, the finished products only that are ready for the market, it's said to be as a stock. But inventory is not that. Inventory comprises of stores as well as materials in transit, materials in process, finished products, and stocks lying at the company's showrooms or warehouses or distribution centers which have not been sold. So inventory involves all these kind of materials, whether it is in a status of transit or transportation, in a status of processing, status of finished products, or stocks that lying as idle resources without being sold. All this comes up with inventory. So physical resource that a firm holds with the intent of selling or transforming it into a more valuable state, then these are usable but idle resource. This transit materials in transit can be used, can become a finished products after some processing, so it can be made ready for the market. Likewise, the finished products are also ready for the market. So these are usable materials, but right now they can be lying in an idle resource state also. Now we will see a case study on inventory control, and this case study reveals that if the inventory control measures are not being done properly in a production unit or an organization, this can lead to a large amount of issues or problems. And Best Buy is one of the largest MNC in UK, Canada and Mexico, which mainly deals with electronic goods. And in the year 2011 December, they faced a major issue. They have provided a large number of offers on their online site bestbuy.com, and it has attracted a large number of customers to it, but they were not aware, or they did not analyze the exact number of stock or inventory they had with it. So they faced an issue that they could not provide the material corresponding to the orders they received. So instead of delaying the shipping, they have to forcefully cancel the orders, which indicated that they oversold the products they do not have in stock. So if the company or the organization is not having an account of what is the inventory strength, what are the materials in transit, what are the materials in process, what are the materials in finished line, they will not be able to go up with the business. So this is a good example of case study that you can take into consideration on studying the inventory control. A similar example or a case study has occurred in the case of Walmart, which is another big MNC in US, and you may please refer this one to understand how the inventory control deficiency has caused a major issue in Walmart. And now we will be seeing the inventory control. And in inventory control, as the definition says, it mainly deals with two things. It ensures that proper and smooth flow of materials is required. At the same time, the total cost of investment in inventories is also kept at a minimum. So as part of a company we are dealing, or organization we are dealing, or a production unit we are dealing, the company should have sufficient amount of stock or inventory materials so that its production process does not interrupt at any point of time. There should be a proper and uniform flow of materials throughout the processing unit. For that, proper inventory control should be maintained by the company. At the same time, they should ensure that the investment the company is providing for keeping these inventories should not be very high. It should be kept at a minimum. For example, if you are talking about a stock of a shop, we know that this particular product is required by around 20 to 25% in a year, all around the year. But there is no point for the shop to have a stock of about 100 to 150 per year, because they have a large amount of money to make the stock, make the inventory. At the same time, it will be very difficult for them to stock them. So for an economic point of view, for an inventory control point of view, they will have to analyze how much products will be sold by the company or the shop in a year, how much customers will be there, and they have to make the stock or inventory according to that. So if it is around 20 to 25 means, for a buffer zone we can keep around 25 to 30, and there is no chance of having more than 30 customers for that particular product, we know, then we can make the inventory control possible. Likewise, This is a planned method whereby investment in inventories held in stock is maintained in such a manner that it ensures the first one, proper and smooth flow of materials needed. At the same time, the cost of investment in inventories is kept at a minimum, keeping the investment in inventories to a minimum. At the same time, ensuring uniform and smooth flow of materials is what is meant by inventory control. Then knowing where your stock is and ensuring that everything is accounted for at any given time. The activity of checking a shop stock is said to be as the inventory control. So what are the areas of inventory control we have to take into consideration? It starts from procurement till the product is being made ready for the market, receiving goods from suppliers, dispatching goods from the procurement section to other departments, preventing shrinkage or shortage of materials, controlling product waste, optimally utilizing this one, efficiently utilizing this one so that the output remains very high. Next one, controlling product safety. So these are the areas of inventory control, starting from the input as raw material, procurement, processing stages, and finally it becomes a finished products. So these are the areas of inventory control. Now we'll be seeing the functions of inventory control. Functions of inventory control are nothing but mainly based upon those 2 points. The first one is that the products should be made available throughout, which means a smooth and efficient flow of materials should be made available and through the entire process of the processing unit. At the same time, the next important point is that it should be provided, it should be the investment for the storing of this material should be very minimum. So based on those 2 points, we can formulate what are the functions of inventory control. First one, separate or isolate different operations and make them independent so that each operation can be performed economically. Maintain smooth and efficient production flow. Purchase in desired quantities to nullify the effects of changes in prices and supply. Keep a process of continuously operating. Keep a process continuously operating. So the second point, maintain a smooth and efficient production flow, and the fourth point, keep a process continuously operating, were the major 2 points which we have discussed in the definition of inventory control, which drives as the major functions for inventory control. So protecting inventory from losses due to improper handling, storing, and unauthorized removal from stores. Pricing all materials supplied to store, create a motivation tempting the customer to buy more, which means that this point refers that all materials or all inventory in the company should be properly accounted, so that the company manager or the company officials will have an idea about what is the inventory stock available with them and whether there is any malpractice by the workers or some other parts of the company. So this actually the Best Buy company did not actually have this function, therefore they were not aware about the exact condition of their the exact condition of their inventory, therefore they have to go over with cancelling of the orders. So next one is to create a motivation effect, tempting customer to buy more. If the customer understands that this company has got ample stock, this company has got ample amount of inventory stock available with them, then that will provide a motivational effect for the customer to buy more and more. So strictly speaking, these functions are mainly based upon 2 things, and based upon that we have discussed the functions of inventory control. Now we will be going to see what are the different types of inventories. Inventories can be mainly classified into direct inventories and indirect inventories. So this portion, including the manufacturing inventory and merchandise or trading inventory, tells us about the direct inventory, while this portion, which includes goods in transit, buffer inventory, anticipatory stock, decoupling stock, cycling inventory, this all things tells us about the indirect inventory. So first we will deal with, most of the terms are not familiar to you, so first we will deal with what is meant by direct inventory. Direct inventory can be classified into 2: manufacturing inventory and merchandise or trading inventory. Manufacturing inventory and is further classified into raw materials, work in progress or process, finished goods, packing materials, MRO, which is maintenance, repairs and operating, and this one, and the merchandise or trading inventory are all other materials that can be taken into consideration. So direct inventories are mainly consisting of the items that are directly used for production or the manufacture. In this one, we could see that raw materials in the procurement stage, work in progress or processing stage inventory, finished goods, the goods that have already been finished and ready for sale, and packing material inventories, and MRO, which means maintenance, repairs and operating inventories that are required for the finished goods. And merchandise inventory tells us about the cost of goods on hand, and those are available for sale at any given time. So this tells us about the direct inventories, and now we'll be seeing about what are the indirect inventories. Indirect inventories are items that are needed for production or manufacture, but those are not the finished products, those are not ready for the markets. Those materials or items are supplementing the production of the main products. So first one, we will see the goods in transit, which means that the goods or inventory materials that are under the transportation phase. Next one is the buffer industry. Inventory, beg your pardon. So buffer inventory is nothing but those inventory or items that a company or an organization will have in its stock in order to meet uncertainty or uncertainties in the market. For example, if we are facing the situation right now, COVID-19, each company will be having a certain amount of buffer stock in order to meet the demands of the public in cases of uncertainties. Next one is anticipatory inventories, and those stock or inventories that are made in anticipation of an event is said to be as an anticipatory inventory. Then decoupling stock or decoupling inventory is nothing but when we have to decouple or separate two parts of a production system, those materials that are required for those purposes is said to be as a decoupling stock or decoupling inventory. Next one is it's not mentioned here, it is not a seasonal inventory, which is defined as the items that are required to meet high seasonal demands. The next one is a cycle inventory, and cycle inventory means it's also known as a working stock that is available to meet the normal demand during a given time period. So I hope you have got an all idea about the types of inventories. Type of inventories can be classified into the direct inventories as mentioned here, and these are the indirect inventories that supplement the direct action or that supplement the actual processes, that is said to be as the indirect inventories, and the major one is the direct inventories. Next we'll be going to see about two different inventory control measures or methods which are being taken into consideration. The first one being economic order quantity, EOQ. The next one being ABC, always better control. The first one, EOQ, is a inventory control method which is based upon two questions. If you are able to provide answer for these questions, this is the control measure or inventory control method that can be used. The first one being how much to buy. The second one meaning when to buy, which means that how much of the inventory material is to be bought and which is the correct time to buy it. So how much to buy is the decision is based upon the cost involved. The second one is based upon when to buy now or to wait. In that we have to weigh the risk of stock out versus the cost of holding extra inventory. So when to buy means first we have to analyze when our stock will become out of stock. So if you are able to take that risk, or we'll be weighing the cost of holding extra inventory. We have to weigh between which one is better, to become out of stock or to provide or invest more amount on stocking more inventory. We have to weigh that and then we have to take the decision. So it tells us about how much to purchase and when is to purchase. One of the techniques for inventory that minimizes total holding cost and ordering cost for the year. It solves the problem of a material manager. So as we have seen, one of the major issue dealing with material management is the amount of inventory that is to be stocked, whether the inventory is ample, less or more. If the inventory is more, sometimes they may be on the safer side, but the cost may increase. So it is up to a material manager to analyze what is the present situation, present market condition, present situation of the company, and to decide how much is to be kept as an inventory and when the remaining has to be bought, or when how much has to be bought. So we will be seeing EOQ in detail. So when we are studying about EOQ, we have to take into consideration two major costs. The first one is ordering cost or buying cost, and the second one is the carrying cost or the holding cost. The ordering cost is nothing but the expenses incurred to create and process an order to a supplier. So if you are giving some order to the supplier and the supplier is supposed to provide us the material, then the cost incurred in providing that order is said to be as the ordering cost or the buying cost. So always the ordering cost increases with increase in numbers. So if we are able to reduce the number of orders and increase the number of commodities in each order, then we will be able to reduce the ordering cost. Otherwise, if we are providing many number of orders with each order having less number of commodities or materials, the ordering cost may be very higher. So it's always necessary to reduce the ordering cost, and the only way in which we can reduce the ordering cost is by reducing the number of orders. Reducing the number of orders means in each order we can keep more amount of or more number of commodities, so that the number of orders can be reduced. Likewise, the ordering cost or buying cost can also be reduced. So what are the costs that are incurred in the ordering cost? Cost to prepare a purchase requisition, purchase requirement, cost to prepare a purchase order, the conveyance charges, cost of the labor required to inspect goods when they are received, cost to put away goods once they have been received, cost to process the supplier invoice related to an order, cost to prepare and issue a payment to the supplier. So in this region we have seen most of the courses in the elements of material management. In the elements of material management, we have seen the inspection of the goods, in reception of the goods, then the invoice reception and issue and payment, and all those things has been discussed. So these all costs create the ordering cost. So if we can reduce the number of orders, then the ordering can also be reduced. So as we have already discussed, the total amount of ordering cost that a business incurs will increase with the number of orders placed. The next one is the carrying cost or the holding cost. Carrying cost is nothing but the cost incurred by the company for holding the inventory, or investment done by the company for keeping the stock for a long period of time is said to be as the carrying cost. So this also tells us about how much we should buy. When we are buying, we should be able to understand how much cost. If we are going to buy a large amount of material and stock it for a long period of time, then the company must understand the amount that is to be raised for proper storage of these materials. So it is expressed as percentage, about 25% of the unit purchase cost. So as we know, when the volume of inventory more, when the volume of the material to be stocked is more, increases, the cost for the carrying cost or the holding cost also increases in number. So this linearly increases with increase in quantity, and it is linearly related with the quantum of the inventory. So like we have seen for the ordering cost, there are different costs that are related or that comes under the carrying cost, which expresses around 25% of the unit purchase cost. And this involves the expenses of putting the inventory in storage, the salary and wages of the workers who are doing the storage activities, maintenance for a long period of time, all utilities used in carrying the storage, which means that the materials, as we have seen, may be of different category. Some may be requiring specific care, some may not be requiring specific care. So if, for example, our material requires much care and it has to be properly stored in a good hygienic, good condition, then we have to have all the utilities for storing the material or inventory for a long period of time. So we may need to have the maintenance for a long period of time, we may have to provide the salary and wages for the workers who are doing the inventory or storing processes, and all this cost comes together, and those comes under the carrying cost. So for example, this 25%, this numerical can be formed from various factors like obsolescence. Obsolescence means the reduced value over a period of time. For if we have to store the material for about say 5 years, and after the 5 years the value of the material gets degraded from its initial time, so those has to be taken into consideration, that is accounted for about 10%. Then interest in inventory, investment payment, physical deterioration that can occur 5%, distribution or handling or transportation 3%, tax, insurance or rent for storage etc. accounts for about 1%, altogether summing to around 25%. So this much tells us about EOQ, the basics of EOQ. EOQ mainly answers two questions. First one is how much to buy, second one when to buy. And in how much to buy, we have to understand two main costs. First one is the ordering cost, and we know that the ordering cost increases with increase in number of orders. Second one is carrying cost or holding cost, the cost that the company need to have for storing the material for a long period of time, which increases with increase in number. So we have seen all those stuff, and then we'll be seeing the next part. Now we have seen how much to buy, next we'll be seeing when to buy. So when to buy, at which point we have to initiate the buying process or reorder process, it is said to be as the order point or reorder point. And there are some technical terms like lead time, and I will explain that with this figure. And for example, the x-axis represents time, the y-axis represents the inventory level or the material that are in stock. So at 0 time, at the initial time, we have enough stock, so the inventory level is very high. So as the time increases, the inventory level, the material gets used up for the process, and as a result, our stock or inventory reduces. The inventory goes on reducing, and at that particular point, at this point, this is the half of the total quantity of inventory we had it at the initial phase. So we have reached the half space, and then we could see that at a particular point known as the reorder point, when the inventory keeps on decreasing from the initial large point to this 0 point here, we will keep the next order, which is also known as the reorder point or the order point. And we could see in the x-axis the order is placed, and the next point is here. When the inventory level decreases and it approaches 0, we will receive the next order, and the time elapsed between the point where we have ordered or we have given this order and we have received this order is said to be as the lead time. So it involves many things like tendering processes, other processes of receiving the order, initiating the processes like that, but all those time which incurred between the order placed and order received is said to be as the lead time. So if you see here, this inventory level has degraded and it has reached nearly 0, then the order received, then the inventory level again rises back to the higher level. Then we could see that this process continues, the process is going on, and the inventory level let's read it off, and it again becomes the next reorder point. It gets reordered, then takes a lead time, then as it approaches the 0, the order gets received and it becomes the initial high level. So this is the way in which we maintain the EOQ, or we maintain the EOQ based upon the inventory control. A similar kind of system has been seen in the 2-bin system, like working bin and reserve bin in the elements of material management. So this is particularly EOQ. This is how EOQ pensions. So the time interval between the placement of an order and receipt of goods against the order is said to be as the lead time. The same thing that we have discussed here, the time gap between the order placed and order received is said to be as the lead time. So how the time is being incurred in the lead time? Time required by stockist, pre-tender work. We know that this is nothing but we order something in the online without any pre-tender work or contract, so we have to invite tender work. So pre-tender work, tender processing time, transportation time for the worker, delivery period, receipt and inspection time, the time taken in handing over. So this lead time involves the time required by the stockist in checking the correct stock till the time in handing over the new supply or stock to the stockist is said to be as the lead time. So this tells us about when to buy. So I hope you have understood about the two things. How much to buy? It consists of two costs, ordering cost and carrying cost. Ordering cost is nothing but the cost incurred in ordering a particular material, and carrying cost is nothing but the cost incurred in stocking the material or keeping the material for a long period of time as inventory. Next one is the when to buy, which is nothing but explained by order point or reorder point and lead time. This one is a graphical representation of EOQ, and in this one you could see that three colored graphs. First one is a light green, a dark green and a blue, and the x-axis tells us about the order quantity and or inventory quantity, and the y-axis tells about the annual cost. So we know that how much to buy is mainly classified into two costs, ordering cost and the carrying cost. So obviously the total cost incurred is mainly based upon two costs. First one is ordering cost and the carrying cost. So we know that the holding cost increases with increase in order quantity. We have already seen that as the quantity of material that is to be stored increases, the holding cost also increases, because we have to engage new workers, we have to pay the salary for the workers, we need to have much more established utility for storing the materials, much more maintenance cost. Therefore the cost increases, the holding cost or carrying cost increases with increase in the order quantity or increase in the inventory quantity. But we could see that the ordering cost decreases with increase in order quantity. Why? Because we have seen that the ordering cost increases with increase in number of orders. So if we are reducing the orders, means we will be providing more number of commodities in a single order. That is the only way in which we can reduce the number of orders. So the ordering cost decreases with increase in quantity. So ordering cost increases with increase in number of orders, but always the ordering cost decreases with increase in increase in order quantity. So combining this one, keeping the optimum of these two, holding cost and ordering cost, we could see, or we could graphically define the total cost, in which the total cost decreases initially and the total cost increases eventually for a long period of time. So keeping the optimal minimum total cost and optimal order quantity, we can define the graph for total cost for holding as well as setup or ordering cost. It is nothing but setup cost is also known as the ordering cost. It is just having different names. So setup cost is nothing but the ordering cost, and holding cost is nothing but the carrying cost. Then mathematically we can define EOQ as square root of 2AP divided by S, where Q demands the EOQ, Q demands the quantity, A demands the demand per time period or annual demand, S demands the carrying or holding cost of one stock for one period, then P demands the ordering cost. So EOQ incorporates the holding cost, the order cost, as well as the total demand per time period, annual demand. So from this we could write the equation as EOQ is equal to root of 2 into annual usage in units, which is nothing but A abbreviation, multiplied by order cost given as P abbreviation, divided by the annual carrying cost is given by S. We can see the concept of EOQ based on ordering cost and holding cost by an example. Take this case. Suppose a drug A is priced at rupees 1000 per box of 1000 tablets, with 1000 box being used per year. The placement of an order cost rupees 160 rupees. From this it is understood that The annual demand for the mid-drug A is 1000 numbers, and the ordering cost for this drug A is 160 per box per order, and annual carrying cost after delivery is 20% of the purchase price. The purchase price is 1000 rupees. Therefore, when carrying cost is 20% of the purchase price, means it is 200 rupees, which is the carrying cost. If you take into consideration the above equation, which is same as under root 2 AP divided by S, which is also written as under root 2 CA divided by H, we can write it as under root 2 into 160. 160 is nothing but the ordering cost, and the ordering cost multiplied by the demand. Demand is nothing but 1000 divided by the purchase price, 20% of the purchase price, which is the carrying cost, which is given as 200. From this we will be getting the quantity EOQ as 40, which makes that each order should be provided with a quantity of 40. That is the least amount by which this order can be placed, which is the most economical method, taking into consideration the ordering cost and the carrying cost. The number is 40. This is being mathematically proven by this equation under root 2 CA divided by H, or the same equation in the last slide, under root 2 AP divided by S. So when we know that we have a demand of 1000 boxes per year, we also found out that each order should contain 40 boxes. So dividing 1000 boxes divided by 40, we can say, understand that we have to provide 25 orders in a year, which means 25 orders in a year with 40 boxes in each order makes the total demand equal to 1000 boxes. So always we understood the order size. The order size is 40 and number of orders is 25 to be in a year. Then we have to take into consideration each stock will vary between 0 to 40 boxes, averaging 20. We will be taking cube divided by 2, which is equal to 20. So the total ordering cost will be equal to 160. 160 is the ordering cost, and we know that 25 times we have to order. Therefore 25 multiplied by 160 plus 20 into 200. 200 is nothing but the carrying cost multiplied by this average value 20, which makes it as 8000 rupees, which means 4000 is the carrying cost and 4000 is the ordering cost in total. This has been solved, and this 8000 rupees has been found out theoretically based upon our concept of economic order quantity. But if we are not following this concept, and if we are simply randomly taking a number of boxes, for example, we know that we need to have this much of boxes, then if we are taking around, if we require 100 boxes, then the ordering cost remains same. Therefore the ordering cost will be 160 multiplied by we required 1000 boxes per year. Therefore this 100 boxes multiplied by 10, we need to provide 10 orders. Therefore 10 multiplied by the cost incurred for each ordering, which is equal to 160. Therefore 10 into 160 plus 50 into 200. 50 is nothing but q divided by 2. Therefore 100 divided by 2 is 50 multiplied by the number of carrying cost is 20% of the purchase price, which is equal to 200. The amount of cost becomes 11,600. Likewise, if we are not taking into consideration a huge number of boxes, we are reducing the number of boxes and increasing the value, then we could see that if 20 boxes are ordered, we need to order it 50 times, which makes that 1000 orders. Therefore 50 into 160 plus 10 into 200, which makes total amount as 10,000. In these three cases, we could see that when we have followed the theoretical concept of EOQ, the total cost became 8000 rupees. But if we are not following and simply randomly checking on the number of boxes or number of units, then the cost can be 1600 or 10,000. So this is the major difference between what is EOQ. If you are following a uniform good method, then the cost incurred can also be reduced. So another example, ABC Limited is engaged in sale of cement. Its cost per order is rupees 400. There is ordering cost is 400 and its carrying cost is rupees 10 per unit per annum. So ordering cost is 400, carrying cost is 10 per unit. The company has a demand for 20,000 units. So the annual demand is 20,000 per year. Calculate the order size, total orders required during a year, total carrying cost and total ordering cost of the year. So similarly like this, you can simply formulate what is the order size, total number of orders required, total carrying cost, and total ordering cost. Also you can find out. Likewise you can find out the total cost, which is summation of carrying cost and ordering cost. This being solved here, please go through this like we have discussed the earlier thing. Now summing up, we have to deal with the assumptions of the EOQ, and till now we have dealt with what is meant by EOQ, two major questions: how much and when to buy. How much deals with ordering cost and carrying cost. When to buy deals with the time, that which is the lead time, which is the reorder point time, all those stuffs. Then we dealt with the mathematical approach of EOQ as well as the graphical approach of EOQ. We have solved a few examples. Now we are just seeing the assumptions. The demand is deterministic and continuous, and the consumption rate is constant. Basic information on price or unit, ordering cost, carrying cost is available and fairly accurate. Solely ordering cost and carrying cost is the major cost involved in this thing. The process continues infinitely, and if we see that graph earlier on, we could see that this process continues without any interruption. Now constraints are imposed on quantities ordered, storage, capacity, budget, etc. Replenishment is instantaneous. There is no shortage of items. So if we see this, we could see that this continuous, this does not have any interruption. As long as the inventory rate reduces, soon we will be providing the next order, and as soon as then order is placed, order is received, the inventory level increases. This becomes continuous, and then we could see that the order placement is instantaneous in nature, or replenishment is instantaneous in nature, which does not take much time. So all those is being explained here. Unit price rate is constant irrespective of the quantity purchased. Whole order arrives at one time, and there is no partial shipments. We could see here also like there is no partial shipment. The entire order arrives when the order is received, and the inventory level is back to normal at the initial stage. So these are the assumptions of EOQ, and this tells us about the EOQ, which is one of the major important inventory control measure. Next we are going to see about the second inventory control method which is being practiced commonly. The first one was the EOQ, the second one is ABC, which is when expanded becomes always better control, and it is commonly used as an inventory control method or methodology. And when we come into detail with, before we come into detail with the ABC, we have to study how this method has been formulated. Vilfredo Pareto, an Italian economist, while studying the wealth and economic distribution in 1897, found out that about 80% of the total national income and wealth was concentrated in a small percentage of around 20% of the whole population. When we read this, we can understand that this is not much different from what we have seen in the case of India and many other countries. So we can say that this theory was named as significant few and insignificant many. So then they came the conclusion that this can be incorporated with the way in which the inventory control is being practiced in the world. Then he understood that very few number of items constitute about a large percentage of the value of the company. So based upon this 80-20 relationship, or the theory of insignificant few and insignificant many, the 80-20 relationship has been formulated, and then it has been seen that about 20% of the inventory is responsible for around 80% of the total value. So based upon that, the always better control ABC system is being put forward, and he classified this into three: the classification class A, classification class B, and classification class C. In class A, as you could see, it is being stated as around 70 to 80% of the total value of the inventory is being entrusted or rested in around just 10 to 20% of the items. In class B, you could see that about 20 to 30% of the materials account for about 15 to 20% of its value. And in class C, apart from A and B, we could see that around a high quantity of materials, around 50 to 60% of the materials account for about just 5 to 10% of the value. So if you take any example, we could substantiate this class A, class B, and class C. If we could take into consideration of the vehicle Toyota company, we could know that it has got a high-end vehicle known as welfare, which cost around 1 crore rupees, and a single welfare car cost around 1 crore rupees, so its price value is or usage value is that much higher. But if we take into consideration the budget vehicles which put forward by the Toyota for around 15 lakhs, so 5 or 6 cars, for example 5 cars each of 15 lakhs makes 75 lakhs. If 6 means it becomes 90 lakhs. So 6 products or 6 more number quantities as 6 makes the total usage value as 90 lakhs. At the same time, a high-end vehicle, comfort vehicles put forward by Toyota makes around for one vehicle alone cost 1 crore rupees. So that is the difference. So we could see this distribution A, B and C distribution everywhere in different countries and different companies. So this is being explained in the case of ABC. If we could explain this graph, we could see the x-axis with cumulative percentage of items and cumulative percentage usage value in the y-axis. So as the class A suggests, you could see that from 0 to 10% of items account for about 75% of the total price value or total usage value, and that is being explained in class A. The same, the value can either be to the left or the right a bit, but generally speaking, class A is being explained here. You could see that 10% of the item represents 75% of the total value. If we see class B, you could see that it is ranked between 75 and 95 in the y-axis, which means that 20% of the usage value or 20% of the price value, which accommodates between 10 and 30, which means 20% of the items. So in class B, or the medium value, 20% of the material accounts for about 20% of the value. If you see the class C, you could see a greater difference between A and B. In class C, around 70% of the material, cumulative percentage of items, 70% of materials account for about just between 100 and 95, which means just 5% of the value. So this class A, class B and class C designation is being explained in this graph with cumulative percentage items in the x-axis and cumulative percentage usage value in the y-axis. And as we have explained here, in A item you could see that around 70 to 80% of the value accounts for just 10 to 20% of the least number of quantities. So we could understand that though the number of quantities is very less, this materials has got a larger value. So these are considered to be very critical in the company or organization perspective. So this can be ordered frequently and consumed immediately. This requires special attention in stores. This has to be monitored by the top management, since they account for about 75 or 80% of the total value or usage value of the company. So rigid estimate of requirements is required. No wastage of resources and optimum usage of resources has to be followed in this case of A items. In class B item, we could see that it lies middle between A and B. We could see that 15 to 20% of the usage value, and it accounts for about 20 to 30% of the quantity. They are medium valued items and they are less valued than A, middle level of management. So this may not be as critical as in the case of A items. So they can be managed not by the top level of management, they can even be managed by middle level of management. In C items, we could see that this require a large quantity of items, around 50 to 60% of the quantity, but their usage value or price value is very least, as low as 5 to 10%. They can be purchased in bulk to avail large discounts and fair prices to pay, which will reduce the cost of ordering and purchasing. But it is seen that compared to A and B, particularly comparing to A, the C items are of least considerations because they formulate the value of around 5 to 10%. Their value is very less, so they are not be much accurate in its measurement estimation, or they are considered to be as least valued items. So coming into tabular form, we could see the difference between A, B and C. For A, accurate forecast of quantities is needed. For B, we could see that it can be approximate stage, and C, there is no need of forecasting since their value is just 5 to 10% only. The second difference, as we have seen, type A requires senior level or top level of management for purchasing or other activities, middle level of managers, and junior level of managers. In 3, we could see that ordering is on requirement basis because there cannot be any change in the estimation because it can cause loss to the company. So next one is based upon the EOQ basis. Bulk ordering is preferred. Large quantity is required where the value is very less, so bulk ordering is preferred. The third case or the C case. Fourth one, inquiries for procurement need to be sent to a large number of suppliers. Inquiries for procurement sent to 3 to 5 reliable customers. Quotations from 1 to reliable customers are sufficient. So inquiries for procurement need to be large number of suppliers means those are being carried out in a proper contract or tender manner. So they will be receiving quotes from all the persons and analyzing them thoroughly, and based upon that only they will be allocating the supply or they will be allocating the contract. So this is middle level of management or by approximate forecast. So 3 to 5 reliable customers. This in type C, any 1 or 2 reliable customers can be used. No need of much scrutiny in that. The fifth one, strict degree of control is to be followed. Moderate degree of control, relatively relaxed degree of control. As we know, type A consists of the most 70 to 80% of the value. Therefore, strict degree of control is to be followed. Low safety for stock, moderate safety stock, and adequate safety stock is to be practiced in type A, type B, and type C. So these are the basic differences. If they ask about basic differences between A, B, and C, you can write these 6 points along with the percentage values and along with the graph. And what are the steps involved in the ABC analysis? We could see that first one, find out the future use of each item of stock in terms of physical quantities. So first step is to identify the stocks in which we have to take into consideration. The second one is to find the price per unit or unit price for each item. Then we have to find the total cost. How we can find the total cost? If we know which all are the items and if we know what are the unit price of each item, multiplying them, we will be getting the total project cost. Then after that, we will be arranging this high total cost based upon a descending order from the top. And then we will be finding the fifth step, we will be finding the percentage of total cost of all item. Then we will be finding the cumulative percentage, and from that we will be able to understand which are the class A, class B, and class C. So ABC analysis steps is just 6 points, but this require a large amount of work to carry out or to find out which category which belongs to A, B, and C. Let's solve this by seeing a problem. In this problem, we could see that it consists of items from A to J, and annual consumption varies from 300 to 1800, likewise to 80 belonging to J. Then the price per unit is also given in the next row from 10, 15, 10 up to 10 belonging to J. And the first step is that you have to find, in this step we could see that the item is provided. The items A, B, C is provided, and also the price per unit or unit price is also provided. Then our next step is to find out the total cost or price value. How we can find that? We can find that by multiplying the item, each item, its consumption multiplied by the unit price. So for item A, the price value will be 300 into 10, which will be 3000. For B, it will be 2800 into 15, which is equal to 4200. For C, it will be 30 into unit price 10, which will be 300. If we follow this, we could find the price value or the usage value or total value of all the items from A to J. That is the next step. And the next step, as we have discussed in the steps under ABC, we will be listing them from the descending order of their total usage cost or price value. So we could see that the third column, we could see they are arranged in the descending order from 42,000, 22,000, 9,000, 7,000. These values, remember that these values are obtained from this value. So there is a mistake. This one 2,800 into 15 is 42,000. 1 0 is missing here. Please take note of that one. Then 42,000 descending order. Then we have to find the cumulative usage value, which is nothing but 42,000 plus, for the second item, it can be 42,000 plus 22,000, which makes it as 64,000, which can be cumulatively added with this 9,000, which makes 73,000, and this can be added up till it becomes 94,300 for the 10th item or the 8th item. So then we could see that we'll be finding the percentage of cumulative value. This cumulative value corresponding to the first item is 42,000 divided by 94,300 will give you the 44.54 cumulative usage percentage. Next one, for the second item, 64,000 divided by 94,300 will give you 67.87 percentage. So likewise, we'll be doing it and we'll be finding the 10th item, we'll be getting the cumulative usage value was 100 percentage. So these are the steps involved mainly in finding the ABC analysis. And from that, we can plot this graph with percentage of cumulative items in the x-axis and percentage of cumulative usage value or price value in the y-axis. And plotting those cumulative percentage 0, 44.54, 67.87, we'll be getting up to 100 percentage. We'll be having this graph. From this, for example, I have taken the case for 20% of items as class A, 40% of items for class B, and from 40 to 100 as class C. Like I said, when I explained this one, this is generally from a certain range of percentage, so it can be changed either to the left or right a bit. So in this case, when 20% of the items are taken into consideration, which comes under the class A, find out what is the cumulative percentage of usage value or price value which corresponding to the class A. Next one, for class B, which accounts between 40 and 20%, which means that 20% of percentage of items which accounts for how many amount of usage value. For class C, it accounts for about 60% of the items, and tell me what is the corresponding value. So find this thing and do message me or inform me what is the corresponding value of usage value or price value corresponding to class A, class B, and class C. And that was a question regarding ABC analysis. Now we could see the advantages and disadvantages of ABC, and this we know that it is nothing but advantages of ABC. ABC helps to understand or prioritize the materials. We can prioritize which material gives you the most value. If it is A material, we can identify the A material and we can prioritize it. We can make it as critical and we can give much more attention so that this cost can be increased. And that tells us about this ABC analysis. That is an important advantage of ABC analysis. And what is the disadvantage of ABC analysis? You could see that this ABC analysis is mainly based upon only value. They are taking into consideration only usage value or price value. If we have to take into consideration some other factors other than the usage value or price value, then ABC analysis is not correct. So sometimes we may have to give importance to C items than A items if our criterion is not price value or usage value. In such cases, you have to take into consideration some other analysis. So next, this is also an example. You could read this out of 493 decks. About we could see that around 325 decks, 14% of the category A consume about 70% of the exposure. Just an example, I have incorporated this one. So that's all about ABC analysis. So ABC analysis, we have seen about what is meant by ABC analysis, what is the history behind its formulation, what is class A, class B, and class C. And in class A, we have seen what is the percentage, B and C also, then we have seen a problem and what are the steps involved in finding the ABC analysis. Okay. Next, we are going to deal with two more different types of inventory control measures which are inferior in nature. First one is VED, vital, essential, and desirable. As the name suggests, vital items means it provides shortage creates issues, so it has to be critical ones which need not be compromised. Essential items, if shortage does not stop the work but the efficiency drops down, so this also has to be taken into consideration. Reasonable risk may be taken. Desirable items, they can be purchased as and when needed. They does not create much problem. Even though these desirable items are not available, it does not interrupt the work at any point of time. So this is just an inferior method, VED, vital, essential, desirable method. Next one is FSM, fast moving, slow moving, and non-moving method. And in fast moving method, we could see that analyzes the consumption pattern of a method. In fast moving, we could say fast moving products. They come to the market, they are of high demand for the customers, so they move very fastly out of the market, so they have to be refilled faster. Next one is slow moving, periodic requirements, which means that spare parts which requires periodic changes. Non-moving, which means dead stock around 2 years, which remain in the market or which remain in the warehouse for a long period of time. So that is another inventory control. We can classify the materials based upon fast moving, slow moving, and non-moving also. So we have seen the first part of the lecture for the fifth module of CEPM. Material management part is over. This mainly consists about what is the concept of material management, and then what are the elements of material management, then what is meant by inventory, what are the inventory control measures, then what is meant by EOQ, ABC, and what are the steps in ABC, then VED and FS.